Good afternoon to all. My name is Kannya from the Department of Mathematics. My college name is Saint Antonis College of Arts and Science for Women, Dindugul. And I'm also a student of Junior IAS Academy. So today we will see about the author of Hydrodynamic and Hydromagnetic Stability. Who is the author of Hydrodynamic and Hydromagnetic Stability? The author name is Subramanian Chandrasekhar. He is an Indian American mathematician. Today we will see the author biography. Let's get started. Subramanian Chandrasekhar was an Indian American astrophysicist. He was awarded the 1983 Nobel Prize for Physics with William A. Fowler for theoretical studies of the physical process of importance to the structure and evolution of the stars. His mathematical treatment of stellar evolution wielded many of the current theoretical models of the later evolutionary stages of massive stars and black holes. The Chandrasekhar limit is named after him. Chandrasekhar worked on a wide variety of physical problems in his lifetime, contributing to the contemporary understanding of stellar structure, white dwarfs, stellar dynamics, stochastic process, radiative transfer, the quantum theory of the hydrogen atom, hydrodynamic and hydromagnetic stability, turbulence, equilibrium, general relativity, mathematical theory of black holes, and theory of colliding gravitational waves. At the University of Cambridge, he developed a theoretical model explaining the structure of white dwarf stars that took into account the relativistic variation of mass with the velocities of electrons that comprise their degenerate matter. He showed that the mass of a white dwarf could not exceed 1.44 times that of the Sun, the Chandrasekhar limit. Chandrasekhar revised the models of stellar dynamics first outlined by Jan Oort and others by considering the effects of fluctuating gravitational fields within the Milky Way on stars rotating about the galactic center. His solution to his complex dynamic problem involved a set of 20 partial differential equations describing a new quantity he termed dynamic friction, which has the dual effects of decelerating the star and helping to stabilize cluster of stars. Chandrasekhar extended his analysis to the interstellar medium, showing that clouds of galactic gas and dust are distributed very unevenly. Chandrasekhar studied at Presidency College, Madras, and the University of Cambridge, a long-time professor at the University of Chicago. He did some of his studies at the Yerkes Observatory and served as editor of the Astrophysical Journal from 1952 to 1971. He was on the faculty at Chicago from 1937 until his death in 1995 at the age of 84, and was the Martin D. Hull Distinguished Service Professor of Theoretical Astrophysics. This is the author biography of Subramanian Chandrasekhar. Now we move on to the introduction about hydrodynamic and hydromagnetic stability. Introduction. The equations of hydrodynamics, in spite of their complexity, allow some simple patterns of flow as stationary solutions. These patterns of flow can, however, be realized only for certain ranges of the parameters characterizing them. Outside these ranges, they cannot be realized. The reason for this lies in their inherent instability, that is, in their inability to sustain themselves against small perturbation to which any physical system is subject. It is in the differentiation of the stable from the unstable patterns of permissible flows that the problems of hydrodynamic stability originate. In recent years, the class of such problems of stability has been enlarged by the interest in hydrodynamic flows of electrically conducting fluids in the presence of magnetic fields. This is the domain of hydrodynamics, and there are problems of hydrodynamic stability even as there are problems of hydrodynamic. This is devoted to a consideration of some typical problems in hydrodynamic and hydromagnetic stability. And in this introductory chapter, we shall formulate the basic principles and concepts of the subject. So, this is the introduction of hydrodynamic and hydromagnetic stability.